So,
wait, how'd you guys do?
fourth place. Good.
Oh, hey!
We led our factory team to a championship.
There you go. There you go. We actually, that was the competition-wise yesterday. That was our best finish ever in all the years I've done it. You know.
Last year we got fifth.
We got fifth.
Yeah. And then last year, and then this year we had like 40 people signed up and ready to go and set up, and then 7 people didn't show up the day up because people were sick and all that.
You should have called me up.
I don't have your number.
Yeah, I will, like, I didn't mean it like that. I meant like.
I wasn't going to call you anyway. Well, it was kind of class made stuff, and everybody did really well, so it was pretty awesome. So,
Except for AJ.
Yeah.
AJ, what happened about that?
AJ, whenever you see AJ, ask him if he's got his answer sheet with him. So, what happens is you're given the test stuff, and then you have an answer sheet. So you do your work and you write your answers on the answer sheet. All you do is turn in the answer sheet. He did all the work and did all of his answers on the sheet. Didn't have any answers on his answer sheet. That gave us, how many points did that give us?
So you guys could have gotten like third place or something like that?
No, that was in your
That
competition.
was in factory, but the rest of the people did pretty well. So.
Yeah, so that's why they guys were winning and stuff. It worked out.
Yeah,
Worked out nicely.
That's why.
So it was funny. It was kind of along the same lines.
Like, Ali didn't get that one problem right.
What happens is they had 4 people take the test and they take the top 3 scores. So they basically went in with just 3 people and they won. So that's awesome.
I gotta be on the test.
Congratulations.
Yeah, I was so happy when I started that.
I put it in the late last night. I'm going to give them back to you guys hopefully tomorrow. I had 2 people that can finish it out. They were accounts, so I make sure bookwork. I want to start with the bookwork, go over that, and then we're going to go back to the worksheet from yesterday and talk about a few of those. So, in the book stuff, particularly if you want to double check on the book. Yeah. I think so. I think that's what it was. 26, 27, 28. There you go.
Mr. Murphy, did you like? Because I swear I didn't get everything right. Did you like take some like information?
No.
I swear I messed up on something.
Yeah, you just substitute. Yeah, it's all substitute. In the rule.
You're gonna get an answer, or you're like finding.
You should get answers. You're using that A and the M. Yes, ma'am.
Okay, so for that section where it said evaluate the special values in your calculator.
Yeah,
like,
don't use the calculator.
Maybe.
You're not going to be able to use the calculator when you do that on the test.
Well, no, I have trouble, like, you know what, the thing on the board behind you, that when you convert it into the A equals 1 over N, I get confused on how you're supposed to, I just can't do it. It messes with my head, I can't do it.
Well, you don't want to solve it with a fraction. You just rewrite it as an n through. They're just synonymous. That's all it is.
Wait, do you know what? Did you take the answer from 36 or 12?
Yeah.
Yeah.
Mr. Murphy, is it okay for that if you just write down the answer from the calculator too, but you also wrote like the exact thing and move forward?
Yeah, we'll get to that here.
Because like this isn't a clean number, but I just
That is.
What?
Yeah, it is.
Clean number.
It's a clean number. Watch. This is telling you to take the cube root of negative 27 and then raise that to the negative 4th power. What's the cube root of negative 27? Negative 3 to negative 4. Is that negative 3 happy? No. Where is it happy?
Wait, so you mean the 4 is not happy?
No, what's not happy? The negative 3. No, it's happy. Yes, sir.
What I did was, how come it doesn't work when it's like this? Isn't this equal to negative 27 to the negative 40 units.
Yes.
But I did that and I didn't do that.
Hit math that around.
Oh, is that end up being that fraction?
Yes, ma'am. Gotta try to stay away from the calculators on these things, guys, because I'm not gonna let you use them. 40, same. It's the same basic idea. You're taking the cube root of negative 125 and squaring it. So this is the cube root of negative 125 raised to the negative 2. That's negative 5. Negative 5 to the negative 2 is 1 over.
Mr. Murphy, what if you just put it all, I put it all over one head?
That's fine. Nothing wrong with that. Nothing wrong with that. Yeah.
So actually, there's the negative 5 to the negative, I'm just going down here, it turns into 1 over 5.
This is, it's not happy.
Okay.
No, it's happy.
The negative sign will turn into a 1 above.
What about 58 and
I would say.
Are those supposed to be clean numbers?
Which one?
Are 58 and 58 supposed to be clean numbers?
No,
Good. Then I'm
because
fine.
this is round to two decimals.
All right, that makes sense.
When appropriate.
I just like thought.
Can you just like, I mean, I got the answer right, but like, can you explain just why 2 to the negative 1 is like 1 over 2? Because would then it be 1 over 2 to the first, and that's why? Oh,
It's exactly what it is. Good conversation.
just had to talk about it.
All right, make sure your names are on that one, pass it up, and we'll talk a little bit about the worksheet yesterday. Oh, while you're doing that, I don't know if you've seen this from Mr. Buckner yet.
Oh, that's a good picture.
That is a good picture. That's what you say with.
Oh, there's Mr. Boyd.
Sam Buckner, not Mr. Buckner, sorry, excuse me, from Sam in the yearbook stuff, and this is what the picture he took on that day.
That's so cool.
Like half the picture.
Yeah,
That's pretty.
that's pretty cool. Yeah, he showed me that yesterday, and then Maddie emailed it to me this morning.
Wait, were
That's
those
like a wallpaper that comes
cream
in.
Oh, okay.
Yeah, I think gold is too cheap to buy pie. It's a whipped cream pie.
No, well, it's cheaper by
An actual pie, the face wouldn't be as good as just a plate full of.
Yeah, because
Correct.
it wouldn't splatter as much.
If it was like really hot, you guys out of the oven, you're like, but it would be
Look, now we're getting it.
apple pie.
Oh, that's what you were here, I forgot to listen.
That's exactly what
Actually, I just handed it in over here just to sit up. So yeah, I just thought it was a really cool picture, I thought it's kind of funny.
There we go. Put that on your website.
Yeah, I probably should, so you guys see it. From what I've been told with yearbook stuff, I guess that's actually going to be its own page in the yearbook.
Yeah.
It's kind of cool. I'm so famous. People. All right, so let's look at this thing, which began with some fun. Now, what class are you guys in right now? Honors Algebra 2. Okay, so that means that it's not always easy, right? Okay. Now, if I take number 2 off the first page, the first page is pretty easy.
Yes.
Multiply out, FOIL, factor, go through that, check for extraneous solutions. All right? Okay. Now, when I go to the second page, you have to work with the fractional exponents. Which means you have to turn your fractional exponents into values of 1. So I left a couple of examples on the board. Hopefully you would notice I was just using reciprocals to replace them to simplify out. Now, when I'm looking at this secondary page, if I just, for example, I want to look at 14. It's kind of a good example of a multi-step with funkiness. Just using order of operations tells me the first thing I do is add 9. You okay with that?
Yeah.
All right. So if I'm just using order of ops to add 9, that's what it is.
It becomes 12,500.
Oh, I guess I did that. Yeah, so you wind up with 12,500 equals 4 times all that junk.
One less here. One less here.
Times all that junk. Divided by 4, right?
Yeah.
Okay. When you do that, you get 3.
125.
You okay with that?
Yeah.
How do you undo the fifth third column?
3
3/5. So I'm going to raise all this to the 3/5, which alleviates that. Okay?
Will we be able to use calculator for problems like this?
You have to on some of these.
Okay, good.
So you go to the 3/5 here. And now at this point, then you get, what is it? 125 equals 31. And you work your way through that.
We did that, but like it's fine if you just like first take the cube root and then.
Yeah, absolutely. Remember, your calculator, I don't know if you've noticed this, your calculator, if you type in, let's get low. Here we go. 3125. Maybe. 3, no. Yes. If I raise that to the, let's say I want to put it to the, was it 3/5?
Yeah.
Just put parentheses, 3 divided by 5, better.
Wow.
Or you could just
Take the 5th root and multiply, and then cube it. You can do that too. The alpha y equals if you want as well. But sometimes it's quicker just to go into the parentheses style. Yes, ma'am.
So it's like the constant for the exponent is like 2, 4 to
Absolutely. And that's all it is. It's just working backwards in order of operations and just deal with reciprocal exponents. Yes, sir.
So, like, when did we learn that? I don't remember learning that.
We
Like,
didn't.
You can get rid of 5.
We didn't. I was pushing.
You're just supposed to infer it off the board.
Right.
Yeah, the circles around.
I was showing you, and I was showing you that's, oh yeah, you weren't there yesterday, but I was just leaving it up to you guys to try and see if you were able to take it that step further, because now that you know that 1/2 power is square root, correct? How do you undo square root?
Square it.
Square it.
What's the reciprocal of 1/2?
2 over 1.
So it's squared.
Correct. Cube root is 1/3, correct? How do you undo cubing? Cube it, which is 3 over 1. So you're working with reciprocal properties that you guys probably just didn't realize you were doing that. That's why I gave you that secondary page. Now, if you didn't get them on that second page, it's not the end of the world. From what I've heard earlier today, that the second page, once they realize it's just reciprocal work, it's a breeze. Then it gets to the last page.
Yeah. I looked at it and I thought about it.
You can think about
It
it.
happened.
Now, when you look at this, yeah, of course that's easy. It's b over a squared.
Oh, it is.
All right. Now, when you think about this last page stuff, isn't this last page just this stuff? Same base, different exponent. When you're multiplying together, what do you do? What do you do with the exponents? How? You add them. It just so happened that your exponents were fractions. So you had to add your fractions. That's the only thing that's different. 5/4. And we're going to get to that today. But I do want to show you how to do number 2. So let's go back to the front page on number 2. Number 2 is tricky, and I was hoping that you guys might have caught that. I'm not going to lie, number 2 of all the problems on this sheet, this is the most complicated. Because there's some nuances in here that you probably don't know about.
Mrs. Smith had said that you have to like move the radical and then FOIL with the radical.
All right, here's what we do. Square root of 1 minus 2x is going to equal square root of negative 3 minus 7x minus 2. All I do is I move the one root to the other side. We okay with that?
Sure.
How do I get rid of roots?
Square it.
Square both sides. On the left side, it's easy. 1 minus 2x.
Right.
On the right side, I'm going to show you something here. Is this a minus b quantity squared?
Yeah.
So that's a squared minus 2ab plus b squared?
Sure.
Isn't that what that means?
Yeah.
Okay.
Oh, because I forgot you had to square it.
It's the same thing.
I don't know what
I tried to kill him.
Squared the first term. Multiplied the two terms together, doubled it. That's where I got the -4. Squared the last term, that's where I got a +4. You okay on that?
Oh, it's just A, B, so you have to keep that radical.
Yep, gotta keep the radical.
Right.
Stick with me here. On the right-hand side, do you agree it's 1 minus 7x?
Right, right.
Okay.
1 plus, what, yeah.
So it's 1 minus 7x. So I'm going to move that 1 minus 7x to the left-hand side. So I'm going to subtract 1, and I'm going to add 7x. And I get,
Wait, no, stop.
What did you, what's one?
what's -3 plus 4?
Oh, that's why you're, yeah, I didn't want you.
Oh.
Okay?
Oh, for the first square.
Subtract the 1, the 1's go away. Add 7x to -2, you get 5x. Right now I have 5x equals -4, root jumped, right? How'd I get rid of -4?
Divide by
Divide by
-4. And then you square it.
You square it again.
Keep going.
Wow. The ones, he's just gonna stop.
You just got to square both sides, went up square both sides twice. That's all.
Ha, when you
Now what's 5 squared?
25.
What's x squared?
Really?
Oh, it's, sorry.
Right.
I didn't.
So the left-hand side becomes 25x squared over 16.
And you got it. And
You okay with that?
minus 3 minus 7.
How do you get rid of a fraction?
Multiply by the float.
No, let's multiply everything by 16.
Oh, yeah, that's it. By the denominator. The denominator. Denominator. Okay, and then, wait, and then you have to make it all into one side. And then you factor it.
I'm not going to factor that. It looks really hard. What am I going to use?
Why did you plus 1?
That thing.
No, I'm not even bothered with that. Look at that. I got front terms of 1, 5, 25, and I got tails
Yeah,
of
probably.
a lot. 1, 2, 3, 4, 6, 7, 6, and a lot. 6, 8, there's a lot of them. Y equals. Here's your Y equals. Go to your table.
Oh,
You go to your table, you will find out that you have a 0 at -4. You have a 0 at -4, but this is a parabola. Parabolas cross, they might cross in multiple places. You know you have one here, and if you look at your graph, it does that. It means you have to calculate that other 0.
how do you do
I'd
that?
rather just.
You use your calculator. There's the button that set you calculate. You go left bound, right bound, and you will find it works out to be somewhat of a clean number. This other 0 becomes -0.48. So your two possible zeros or solutions for this set of problems would be at -4 or -0.48.
What the?
Exactly.
Wait, why is
And then you got to check for your extraneous solutions.
That was unnecessary.
-0.48 is extreme.
-0.48 winds up being extraneous because when you do all the roots, it doesn't equal -2. So this is your only solution. All right? That is a tough question, but it's solving for x and it's working through multiple steps. Honors algebra 2, I'm going to push you.
So we're gonna see stuff like that.
Oh, yeah.
On the test.
But we haven't even, to be honest, we haven't gotten to the full section of being able to do this yet. This was more of, can you get it? If you got everything except for that problem on the first page, you guys are fine.
You sound like that.
Let's do 7-2. We're going to save this. We're going to come back to this later on. Yes, ma'am. I use the calculator. I use the second calculate function. Look at the intersect for 0.
Wait.
So I want to get into 7-2 because I want to talk about those with a lot of exponent rules.
So like,
Save it. Don't lose it because we're going to do that last page tomorrow.
what should I do?
I started working on it. I'm not. It's probably going to wind up being just questions that we're going to do. I might not collect it. All right.
Oh, okay.
Yes, ma'am.
I was gonna have to be able to collect that.
I might at some point in time. So I want to look at 7-2. But with 7-2, we do have to spend a moment here real fast and talk about radicals. So anyway, like I was saying yesterday, or earlier today, all these are today is the same idea with your properties. When you have same bases, different exponents, you add them.
I forgot about that.
When you have power to power, what do you do?
Multiply them.
Multiply them.
I'm excited.
When you have negative exponents,
You put it into 1 over h9.
and if it's negative in the denominator,
Then it's 8, yeah.
correct.
We're gonna
Okay.
get these this year.
We've already done all these, yes. What changes today is that they become fractions. That's it. It's the only thing that changes. All the properties of everything that we've always done with these things all still hold true. All of these properties here, they're all right here. Geez Louise, you've seen them all before. None of them are new. None of these are new. Okay? None of these properties are new to you. You've worked with all of them. Okay? Anything with the 0 power is 1. When you're dividing, you're playing the game of war. When you have distribution, you distribute the exponent in each individual term. None. When I
Oh,
talk-
that one's bigger than you.
Yeah.
So take that one and that one. Got it?
Yes. It's the same premise as what they're doing here. It's top divided by bottom. But then sometimes you have to resend it to the bottom if it's a negative value. I like to just say the game of war. It seems to be a little easier. Not a single one of these properties is new to you. What's going to be new to you is how you write them with fractions. For example, 3 to the 1/2 times 3 to the 3/2. It's 4/2, otherwise known as? What's 3 squared?
9.
All you do is add the exponents. Same way we did before, okay? The idea behind this doesn't change. Same base, different exponents, add them. All right? Yeah.
So these properties would not apply at all if it was like 3 to the half and 4 to the 3/2, it wouldn't apply at all?
No, because you can't do that, because they have to have the same base with the exponent.
Okay.
Until you get to the fact where you can simplify radicals to get to the same base, then you can do that, which we'll get there eventually. Power to power, again, all you gotta do is just multiply stuff together. 4 to the 3/2 all squared, just distribute out. 3/2 times 2 is 2. Or excuse me, 3/2 times 2 is 3. Excuse me, I don't know how to do that. Yes, sir.
In the first example,
Yeah,
why won't you times the 2 glues together?
you don't, because you work with exponents. Because remember, when you had this, it was x squared times x to the 3rd. You didn't multiply it 2 times 3, did you? No, you just worked with pair up. Because that value of 3 is your base.
Because it's x times x times x times x times
It's all messed up. Oops. I can't keep saying this. It's just so simplistic to what we've been working on before. I have a lot of little squares in here, don't I?
Jeez, you're like that one lady that wraps the presents.
Like I said, none of this is new. It just looks weird. That's all it is. It just looks different than what you're used to seeing. 9 times 4, all raised to the half power. But they did theirs. They just distributed out the half power to both of them. If you even just did your order of operations, you'd have to work on the inside of parentheses first. What's 9 times 4?
36.
What's 36 to the half power? Same answer, isn't it? Works the same way, guys. These things aren't new to you. Okay? I will tell you one thing. These values, these numbers, things like you see right here, pretty easy to work with. You will have to be able to do this by hand. I'm not going to just say, hey, use your calculator and tell me what 8/27ths to the 3rd power is going to equal. All right? Because you put that in your calculator and press enter. Yes, sir.
Why isn't there a setting on our calculator to make it like the calculators that we use for radicals and math team that like simplify it for you?
These don't have that. I don't know why I don't know why the graphing calculator doesn't have a way of doing that. I don't know.
I could kind of see like why we were using class. It does literally all the work for it.
Yeah, it's one of those things that it's just, I don't know. You'd have to go to Texas and ask them. Texas Instruments.
Hey, this reminds me of the question. When I was with the calculator team,
Yeah,
they're like all wondering like if they could use something called CAS.
computer-aided software.
So like what's
Solver that.
does everything for this? Like, what do you
Can I use that?
like,
A CAS style calculator, there are certain functions that are on there that will do some of the minute work for you. So when you get into the calculus stuff, there are certain things, like some polynomial stuff, that you don't need to crank out by hand anymore. The calculator will do that work in tandem with the calculus stuff. So there's some crazy things that things like that can do. All right. It just,
Can I get one?
I don't know how to use it, so it's not going to do you any good.
I'll teach myself.
Good luck. I will. I would. I know. I hear it's on computers. I wouldn't let you use it in class though. Good luck with that. So, like I'm saying here is, you're going to be able to simplify stuff out. And I just want to show you a couple of these because most of these are pretty easy. For example here, if I look at that 7 over 7 to the third. Yeah, 7 over 7 to the 1/3. What happens here is the numerator, does the numerator have an exponent? It's 1, correct? Now, what I'm going to do is just rewrite it in terms of the same denominator as the bottom part. So can I write that as 3/3? Who wins the battle of war, the top and bottom?
Top, so 2/3 on the top.
So 7 to the 2/3 over 7. Or to 7 over.
You're done. Yeah, at that point you're done, okay? You don't have to simplify, you just rewrite it in terms of exponents. That's it.
Why couldn't you not like 7 to the 3rd and then bring that to the top? Right?
Why?
Well, wouldn't that work too?
Well, you're doing that. We're doing that as the game
But
of
then
war.
wouldn't you get 7 to the 4th?
Nope.
Because then you'd have 7 times 7 to the 4th.
Because it could be to the negative one, or flipping it over the fraction.
Think about your rules. If you're x to the 4th over x to the 1st, the rule says it's x to the 4 minus 1, which is x to the 3rd. All I did here is, these are my exponents, I subtracted them.
Yeah.
That's all it is. It's the exact same stuff. You okay on that? Does that make more sense, Christian?
Yeah, that makes sense.
Cool. All right.
The way that you did it was better though.
What's that?
The way that you did it was better.
Now, it also works the same way as with radicals. Now, you guys have actually done radical properties in the past. You've worked with properties of radicals when you simplified radicals. For example, if I asked you what the square root of 12 was in simplified radical form, you would tell me it's what?
2 root 3.
2 root 3. In order for you to be able to do that, you were searching for a perfect square. You rewrote that in terms of the square root of 4 times the square root of 3. Aren't both of these the same nth root? They're both square roots, aren't they? Yeah. You've been doing this all along, you just didn't realize that there was an n value there. So as long as you're keeping it with terms of the nth root, it works. So you can simplify any nth roots. You're just, instead of, you might be looking for a perfect square, or you might be looking for, come back to this one, perfect cubes. How do you do that? Well, first we gotta remember what your cubes are. What's 2 cubed?
8.
What's 3 cubed?
27.
What's 4 cubed?
32.
64. What's 5 cubed?
125.
That's usually about as far as you need to go. 6 cubed is 216 if I'm not mistaken. But after that, the numbers get so large really fast. All right, it's not like squares. Squares are very easy to work with. Okay. Now, when I'm looking at here, if I've got root 4, or cube root of 4 times the cube root of 16, do they have the same nth root?
Yes.
Which means I can multiply the values underneath the radical together. So what's 4 times 16?
80.
Oh, 4 times 6. Oh.
And is 64, is that a perfect cube?
Yeah.
What's the cube root of 64?
4.
4. What if 3 numbers multiply together they're the same? They get you 64. 4. Not bad, is it? Remember, you've done this before. You did it in terms of square roots, not cube roots or fourth roots. What's that? Time flies when you're having fun. Hey.
That's why.
This is probably like my favorite question.
I heard someone yell for me. What's up?
Okay, whenever you reminds me of the doctor.
It's around me with that.
Yes, now it's stuck in my head.
Oh. I haven't seen it, but okay. I just don't. Cool. And this one here,
Oh, I got it.
notice how we have the same nth root, both the numerator and denominator?
So it'd be
That means I can rewrite this as one giant
4 root.
fourth root of 162 over 2. What's half of 162? Really?
81. 81. 81. Sorry.
What's the fourth root of 81?
3. Wow. That's cool.
Not that bad, is it? Like I said, you've seen this before at some form or another. It's just we're dealing with different nth roots. Okay, the values are going to change up a little bit.
This isn't so bad.
What? We got a lot to do. All right. So we've already done the square root of 12. That's easy. We know how to do that. It's 2 root 3. You knew to break it down. Break it down to the root 4, root 3, so you have 2 root 3. Now if I got to go to simplify the cube root of 54, I'm now no longer looking for the perfect square, I'm looking for the perfect cube.
Oh, so not 9.
2 and 27.
2 and 27, right?
Hold on. Hold on. 7 times 8. If it was 56, good job. Now, in this case, you have to, again, this is what you're asking about. What is going to be the perfect cube that goes into 54? Well, remember your cubes. 8, 27, 64. Well, 64 is already too big, so does either 8 or 27 go in?
27.
So rewrite it. It's the cube root of 27 times the cube root of 2. 3. Yeah. Your answer would be 3 cube root of 2.
Oh,
You're doing the same basic principle where you're trying to find the perfect square per cube. For rationalizing? You're right. Try it. I will check in a minute. What do you got?
Are you just going to throw some major twist at us in a second and make this completely...
Variables get to be a little bit messier, but we'll get to that. We might have chances to try a couple of them. We might have to do more of it tomorrow.
Okay.
So now let's look at the weird stuff.
Oh, so that can be rewritten as... I got it.
Wait, no, that's
I don't know my perfect stuff.
How do you do this? Before we get to here, how do you do this?
It would just be the
Fifth
fifth root of 3 over the fifth root of 4.
How do you do that?
Wait.
Okay? You'd separate them, right? You get root 2 over root 3. Okay? How do you get rid of the root in the denominator?
You square it. That's
Because what's root 3 over root 3?
3. I'm sorry. 1. I'm sorry. I'm getting one step ahead of you. And then
Because isn't this
that's it.
rationalizing? Isn't that equal to 1?
Yeah.
So am I changing it at all?
No.
And you're done, right? Because you can multiply underneath the radical with the same nth root. What do you think you do here? The same stinking thing. Here, I'll rewrite it first. This is the fifth root of 3. Fifth root of 4.
Well, I don't know.
Oh, wait, times.
You don't have to know your fifth roots. What's your denominator here?
The fifth root. So you do the reciprocal?
So, no.
No.
Just multiply it. What did I do here? I multiplied by root 3 over root 3.
Oh, God, that's why I got 1 from it. I'm so stupid.
So wait, now with this,
No, would it be 50
with that,
12?
wait,
It's
wait,
12.
yeah, fifth root of 12.
Christian?
Denominator.
All right. What's square root of junk times square root of junk? Junk.
Yeah, but
What's the fifth root of junk times the fifth root of junk?
John.
Square root of junk times the square root of junk is junk. Fifth root of junk times fifth root of junk is?
Wait.
Okay. 5 root 12.
Oh, Oh,
On
duh, duh.
And then,
Just simple, so just working them out.
Is that-
Slow.
is that as far as you can get over?
Done. Sometimes you find when you go through a little bit more, but right now,
What's 2 to the 5th, 32? So as long as it's like not a factor of 32 or 32.
works the same way when you're adding. What happens if it's 7x plus 2x? What do you get?
9x,
Why is that?
because you combine like terms.
Combine like terms, right?
Oh, so you combine like terms.
Aren't those like terms?
Yes. Yeah, so you
What's
just
7 plus 2?
9 times 6.
Done.
So we don't have to multiply out after that?
Unless there's
You
a.
can't? Okay.
You can't. You
Okay.
can't because it's got different exponents. You can't. You're done.
Okay.
Because if you're looking at it, this is the same thing as saying 9.
Can we simplify
Fifth
6
root.
to the 1 root though?
Is there a perfect fifth that goes into 6?
What, no, so do you want us to write it like that? Or
Would you write like that? That's yours.
I'm glad you asked. A lot of times, kind of the conventional wisdom way of doing these things is if they give you a fractional exponent, you keep fractional exponent. If they give you nth root, you keep nth root. Does that make sense?
Yes.
And that's kind of how I work through these things as well. And I don't really stray so much after that.
Oh, I got it.
Here, I can't combine those, can I?
Oh.
Or can I?
You
Yes,
can
you
subtract
can.
the things inside the no.
Do they have the same roots?
Yeah, so you just do 16.
They don't have the same jump.
They don't have the same junk. I like it. They don't have the same junk.
Can I write that on the
You can't.
That is good, but it's not.
It's not window quality.
It's okay. Get it right on the board. One behind you.
Everyone sees it when they walk in the room.
It's not the same junk.
They actually probably see it on the board.
So, in order to do this, what do you have to do?
Find a perfect cube.
No.
Yeah,
You
simplify it first.
fit the
No. What's the perfect cube that hides in 16?
2.
9. Or
8.
W.
Well, it is technically, well, 8 because 2 is the answer,
Are you okay? You okay with that?
Yes.
So then.
What's the cube root of 8?
2.
2. So you have 2 cube root 2 minus, now I want to put this here.
Isn't that?
So it's just gonna be cube root.
Because what were you going to write? 2, weren't you?
Yeah.
Now what are you going to write?
Cube root.
Wait, now 2 cube
You're
line.
not gonna write anything.
I don't. You read
Yeah.
I know.
Oh, you just write the
subtraction.
You have 1 cube root 2.
Well, you can't get.
I know. I didn't know how to say it.
Oh, because.
Thank you, I totally would have messed that
Oh,
up.
because
It's just like cube root 2 is an X.
It's the same, and that's where most of you guys will mess up because you're not accustomed to seeing it written like that. If you had it as 2x minus x, you hopefully would write x. Oh. Okay? You wouldn't write 2, all right? It's the same basic idea.
I'm trying to get this perfect.
Same basic idea. Yeah, we'll come back to worry about that. The variable ones. Now, bear with me here in a minute. I'm going to show you an example real quick. Might as well. Gonna have to do it eventually.
Oh, yeah. Is that our books
I don't know if I'm going to give you too many. I might just give you 1 or 2.
Yeah.
When I'm looking at this, cube root of 125y to the 6th. I don't want to rewrite it as a fractional exponent. Sometimes you can if you want. I think it's easier to go this route. What's the cube root of 125?
5.
Oh, wait, so you can just separate it. Would it be y squares?
3 goes into 6. How many times?
2.
How many are left over?
17.
Oh, because when you do roots, when you do, because it doesn't, oh, it's like a,
Oh, because it doesn't.
And it works because of the fraction.
You're gonna say over fraction?
It's not bad.
All right.
Bad.
4 goes into 4 how many times?
Once. So x over 2x to the 2. What are you saying? I don't know.
Okay.
Get the next one, next one.
Just all the answers.
We'll come back to these in a minute here. I got another one for you here. I'm gonna write this one out.
It has to be done. That's why I'm gonna steam my work.
Page 5.
The one you can oh, this is like that fraction.
That's a 9. Yeah, sorry.
So b to the, but if there's no
So it's the 5th root of 5, a to the 5th, b to the 9th, c to the 13th.
what do you do with the left?
All right. Can you take the 5th root of 5?
Oh, no, sorry, no.
So, all right. Now this is where it gets interesting. 5 goes into 5 how many times?
Once.
Any left over?
No.
5 goes into 9 how many times?
Once.
How many left over?
4.
Yeah.
5 goes into 13 how many times?
Twice.
How many are left over?
2.
3.
3. Sorry. I'm thinking like that.
Oh, you're gonna use word instead of choosing?
Wait, so you're multiplying ABC times that?
Yep.
Oh, they finally.
You're done.
That is live.
Simplifying radical.
All
right.
In the time that you could
Now, Ms. Ryan, what you were saying with the fractional idea, same basic principle. You go to the 1/5 power. No, we have homework. See, all you're doing is you're multiplying those exponents in. 1/5 times 5 is 1. 1/5 times 9 is 9 over 5, so it goes in there. We have 1 and 4/5 left over. It's the same idea what you were talking about. Homework wise, it's section 7.2. It's on page something. 411. I want you to do numbers 24 to 54 evens. It's all numbers.
Oh, come on. Give
It's
us
all numbers. We're going to wait on variables a little bit more tomorrow. It's all numbers for tonight. Do your best not to use your calculator. That's the stuff you won't be able to use the calculator for on a test or a quiz. Okay? And we'll build off this stuff tomorrow.